Okay, so for this next question, I believe the system of equations that was in my book was incorrect. I'm pretty sure that you guys, let me cross this out, I'm pretty sure that the system I wrote below is what appears in the student's textbook. So let's work with this one. It says Amy thinks that the solution to the system below is -4, -6. Eric thinks the solution is 8, 2. Can they both be correct? Demonstrate that you know who is correct by showing your work for both possible solutions. So this is kind of nice because we're kind of being forced to check the solution to each of these. So for Amy, she thinks that x is -4 and y is -6, and we're going to plug those values into both equations and see if they make it true. So when I plug that in, the first equation is 2 times x, so I'm going to have 2 times a -4, and then to that I'm going to subtract 3 times y, and y is -6. And I'm wondering if that is the same as the number 10. Well, 2 times -4 is -8, and -8, that would actually be plus 18, right? Positive 18. And -8 and plus 18 is indeed 10. So 10 definitely works in the first equation of the system. So far Amy's off to a good start. Does have to work in both equations, but she definitely has a point that works in the first. Let's try the other point of the other equation. So the other equation is 6 times y, and y is -6. So I have 6 times -6. And I'm wondering if that's the same thing as 4 times x, which is -4, and then -20. 6 times 6 is -6, rather, is -36. And is that the same as, this would be -16 minus 20. And -16 minus 20 is indeed -36. So I think Amy's correct, right? Her point, -4, 6. X is -4, y is -6, satisfied both equations. So just for the heck of it, let's take a look at what Eric's got going on. So Eric thinks that the solution is x is 8 and y is 2. So let's go ahead and plug his values in. So in the first equation, we've got 2 times his value of x was 8 minus 3 times 2. And we're wondering if that is the same thing as 10. 2 times 8 is 16, and 16 minus 6 is indeed 10. So actually, he's correct in his first equation, but I suspect that now he's going to fall apart. So let's plug the values into there. Let's see. So his y value is 2, so he's got 6 times his y value of 2, and we're wondering, is that the same as 4 times his x value of 8 and then -20. So 6 times 2 is 12, and then on the other side we've got 4 times 8 is 32, and 32 minus 20 is 12. Wow, that's the same, right? They're the same. So Eric's point to solution also. Oh, yes. And I suspect I know why. These are the same. These are identical equations, right? We're looking at 2 identical lines. That's what this is. If I was to, I guess, I could rewrite them in y equals form. Like if I take this second equation and get y alone, this would be y. Y would equal, say I'm dividing both sides by 6, so it would be 4/6 x minus 20 over 6, and that could be simplified, right? Y is 2/3 x minus, let's see, 10/3. So that's the second equation rewritten in y equals form. Now let me do the same thing with the first equation, right? The first equation was, I'm trying to get y alone, so I'm going to subtract 2x from both sides. So I get -3y equals -2x, and then plus 10. And if I divide both sides by -3, I get y equals negative 2 over negative 3x, and that would be minus 10/3. And you can see, right, the negative over negative makes this a positive 2/3 x minus 10/3. So these lines, they both have the same y-intercept and they have the same slope, so they're the exact same line. So there's a lot of people that could be right. If you have a point that is on one of the lines, it would necessarily have to be on the other line because the lines are the same. So we'd say they're both correct.